All right, today we are doing lesson 6-9 on direct variation. Our three objectives. We need to define specifically what the criteria for direct variation is. Once we know what it is, we need to determine if I provide data, basically in the form of x and y coordinates, does it meet the criteria of direct variation? Second, we will establish equations for direct variation. And direct variation, again, will be represented today as a constant, and it will be the letter k, which also is going to represent the slope. But today, for our purposes, we're going to be solving for k a lot. That's just what we call it with direct variation. I don't know why that's necessarily the symbol that we use, but it is what it is. So we're going to be introduced with another new formula that we can use to figure out the constant and test equations to see if they meet the equation. 3, solving problems by using the direct variation that we're going to learn. And then, this is the key, using proportions. So I'll have to go through and show you exactly what that looks like. But when I say the word proportion, for now, just think about equivalent fractions. Okay? Think equivalent fractions. Okay. So I put a little example right here on the board. And this is just something from the book here. The word problems in this assignment today are by far the trickiest part of this whole assignment. The rest of the problems are nothing. They're very simple to solve. They won't take long or much work. But this talks about here, basically we're talking a carnival. Down here is the number of tickets sold, number of tickets, right? So, and on the other side here, this is the revenue, basically how much money did they make, right? So we should assume that this would be a positive correlated graph, right? Because as the number of tickets we sell increases, our revenue is also going to increase. This is going to be a positive correlation, of course. But direct variation. Direct variation. So if something shows direct variation, right? A good way to test it is to make a graph, right, that shows the relationship between my x point and my y point. And in this case, my x points are going to be the number of tickets sold, and my y coordinates will be the revenue. Right, so that's my two coordinates, and I can plot that. Again, I've rewritten my graph a little bit here, where each space isn't necessarily 1, 2, 3, 4, 5. But this time, I've written my x coordinates in multiples of 100, 50, 100, 150, 200, 250, 300, so on and so forth. And my y coordinates are set in increments of $100. $100, 200, 300, 400, and all the way up to 1,000. So, and that's a perfectly acceptable way to create a graph. So, as long as whenever you're graphing, each line is proportionate, the same distance away from each other, x or y values, whatever they may be, that's perfectly fine to graph it that way. There's nothing wrong with that. Okay? So they provide some information here, and I've already graphed it out, but they're basically saying, okay, we take the day of the week, number of tickets sold, and then how much money did they make, which is also, of course, known as revenue. So we got Friday sales, we got Saturday sales, we got Sunday sales. So on Friday, they sold 205 tickets, and they generated $615 in revenue. On Saturday, 310 tickets were sold, and now they made $930. And then on Sunday, 170 tickets were sold for $510. So there's my information that I have been provided on a table, just like this. You will see these tables. Obviously, it could be any two quantities or things that we're comparing. Pretty wide open here, but in this case, we're just talking tickets sold and how much money did we make. So I can certainly plot that. So for my purposes here, my tickets sold, we're calling this my X coordinate, and the revenue, that's my Y coordinate. And then, just like any other graph, this is my coordinate I can plot, 205 and 615, which I plotted right here. This is approximately 205 and 615, 205x, 615y. Plot this coordinate, 310 and 930. There it is, way up here, 310 and 930. And then my Sunday coordinate, 170 and 510. Boom, there it is. Then I connect the dots, just like we do, draw a line, and here's my graphical representation of the data. Okay? Not too hard, right? So the question becomes, first of all, is this data set linear? All right? So linear, what does that mean? Well, linear is everything we've dealt with so far. If I can draw a line, and it's a straight line connecting all my points, that is a linear set. And for something to have direct variation, it absolutely has to be linear, because we're talking about equal proportions. And we're going to prove that here in just a minute. But if my line is curvy or something else, that is not direct variation. All right? Because if we're moving up and down all over the place, we're not going to have equivalent ratios. Things are not going to evenly move up. Right? So for something to be in a linear function or an equation, when I graph points, they should all fall on a straight line. And in this case, if we look at it there, that looks like a straight line, right? Did a good job with that, right? I think I did. Seems pretty good to me. The other criteria that has to be met for it to be both direct variation and a linear function is it must pass through the origin point, 0, 0. 0, 0 has to be coordinate on the graph. And again, we can use probably common sense here to figure this out here. But if I sold 0 tickets, how much revenue do you think I'm going to make?
0.
0. So 0, 0 is indeed a coordinate that would be plotted on our graph. In this line, if I look at it, lo and behold, it does indeed pass through 0, 0.
Hey, Emma? Yeah, come here for a second.
Right? Yes.
What if somebody just walked by, didn't buy a ticket, but tipped?
That's, again, we're not talking about weirdo situations like this. So this is indeed representative of a linear function that meets the criteria for direct variation. Okay? Now, the best way we can find direct variation, though, graphing, you can do it. And again, you can certainly set up a graph for any of these problems you'll see in your homework, but that's not really the most efficient way to figure out direct variation. You could. All right? I'm not going to be doing any more graphing than this right here, and I think there's a couple problems that you'll have to set up a graph for. Okay. So you can graph any of this stuff here, that's great, but it takes a long time to make graphs. I mean, I made this graph before I started the video because what was the point of saving me 2 minutes making a graph, right? Who wants to see that? Nobody. Very boring. So you could, but not really the best way. Instead, what I could do with the information I'm provided in this table is I can use an equation to basically show if there's direct variation or not. And I promised you new equation, so here it comes. New equation today, y equals k times x. And we're going to be solving for k. This is the equation, but this is not the format that we're going to use it because we're going to be solving for k. Y equals kx. So how can I get it to solve for k? Pretty simple. Divide both sides by x. So k equals y over x. And that is the actual equation that we're going to use, but for whatever reason, it's officially called y equals k times x. But when we use it, k equals y over x. And this is pretty simple to use here. Pretty simple to use. So I don't think you guys are going to have a lot of problems with this. But the test for direct variation, all right, and determine whether the data set meets the criteria, is I go up here, and I can start with my first coordinate. So here it is, 205 and 615. So I plug those numbers in. There's my y coordinate, 615. Y over x, k equals y over x. So 615 over 205. And I can take out my calculator. Maybe you know it off the top of your head, and that's great. But if I punch it in, I get 615 over 205 equals 3. Now that's my slope. Now again, if you look at this here, it's hard to see it because the space between each point is actually quite far. So it's very hard to see. If I had a tremendously large graph, we could figure out it meets the criteria of every one spot I would move to the right, I'd move up 3. But again, you're not going to see the slope the way you think you'll see it on these graphs because, again, I am not graphing 1, 2, 3, 4, 5. I'm graphing in sets of 50 this way and sets of 100 this way. But that actually is the slope. That actually is the slope. So, but what I need to know is my constant. I need to know k, and we call this the constant of variation. All right, k is the constant of variation. Okay. So if a line meets direct variation, all the slopes or the constants for all my coordinates should be the same. So when I plug in 930 and 310 into the same equation, I should get 3 for an answer. And when I plug in 510 and 170 in, I should get 3 for an answer. Yes?
So we're just looking for the slope.
More or less. Yeah. But it's the constant variation. So 930 divided by 310 is indeed 3. And 510 over 170 also equals 3. 3 equals 3 equals 3. They all have the same slope. They all have the same constant variation. Therefore, this line does indeed have direct variation. Passes through point 0, 0. Not too hard, right? Right. Okay. So we're going to look at a couple different things here. Again, my expectation or what I'm thinking here is you guys will pick this up pretty quick. How are you going to see it here? So it'll say, find the equation of direct variation. That's something you're going to do a lot today. It'll say, find the equation of direct variation. So that's basically 7 through 18. Find the equation of direct variation. Given that y varies directly with x. Great. So here we go. Let's try some out. So what you'll see is y equals 12. Right? When x equals 3. This is exactly how you'll see them in your homework, just like this. Just like this. So I go back to my initial equation that we said, y equals k times x. So this is how I'm going to represent my final answer here. So before, this is the format that I'll use to represent my answer. But for the moment here, I need to go k equals y over x. K equals 12 over 3. K equals 4. And then all I merely need to do to finish this off, plug it in there, y equals 4x. Solved. Done. That's all there is to this. All right. And again, if we remember y equals mx plus b, we don't have a y-intercept necessarily, but this, of course, is my slope, right? This is my slope. So this formula, basically slope equals y over x. That's all there is to this here. There's not much more going on. So we'll do, maybe I'll let you guys try one. Yeah, I don't know what else is there. There's a couple other things I got to show you, but y equals 21 when x equals 1.5. So write the equation of direct variation for me. Write the equation of direct variation. That's it.
Oh my gosh, division in multiplication.
Right there. That's it. All there is to it. Yeah. No. You just make a really tiny little graph in here. You really want to be,
You should use my graph paper, even though it has the end.
correct. That's it. Alright. See a hand waving. Flying around like you just don't care. So where's my final equation? You're right.
Oh.
Everything's good. I can plug that in back to the starting equation. Y equals
Yeah.
3x.
I told you. I like to say
That's
anything.
it. That's it. Yep, that's it. All right. So most of you did pretty good. Little slow, but we'll do another one or two. You'll be pros in a second. So there's the format that my equation needs to be written in. But I need to solve for k first because I know y, I know x. What I'm solving for is k first. And once I know k, this is the format I write my final answer in. So k equals y over x. My y coordinate's 21. My x coordinate's 1.5. 21 divided by 1.5 is 14. Now I merely plug that in for k, because that's what I solved for. K equals 14. Right? K equals 14. Y equals k, which is 14. X. Solved. So, okay. Give me another one. One more. Okay. Here we go. Y equals 35.1. When X equals 13.5. So, provide me an equation of direct variation. Provide me an equation of direct variation. Having your calculator, so probably help you out here. So again, direct variation, use my formula y equals kx. Gotta solve for k. K equals y over x. My y coordinate 35.1. My x coordinate 13.5. Divide out. And you get 2.6. K equals 2.6. And it goes y equals 2.6x. Easy peasy. Easy peasy. Alright. So there's that. That's the bulk of the homework. Couple other things here you gotta be able to do. So it says make a graph. Again, this is basically, you are just, quiet please, taping. The graph, just like I showed in the first place, this is another method if I don't use this mathematical method here to figure out if there's direct variation or not. You should, if it hits direct variation, all your points will connect into a straight line, and it will pass through the origin of 0, 0. Those two things must happen. All the points that you graph will form a straight line, and it will pass through the origin of 0, 0. Those two things need to happen.
Can I borrow a popsicle stick?
What?
For what?
I need to loosen my watch.
Yeah. Okay. CJ, quiet please. Video. So here we go. So it says make a graph. I'll do one. I'm going to use my graph here. And you'll be presented with a table. On some of your homework problems here, it just says ratios. So I'll do that. But I'm going to graph one. No, I'll use the find proportions method for the other. So distance over time. So distance, 90 miles, 3 hours. 120 miles in 4 hours. 150 miles, 5 hours. 180 miles, 6 hours. So distance, I'll put that here. and time in hours. So we'll say 1 hour, 2 hour, 3 hour, 4, 5, 6, 7, 8, 9, 10 hours. And distance, I'll just put in increments of 30, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. Alright, let's graph. 3 hours and 90 minutes, right here. 4 hours, 120 minutes, right here. 5 hours, 150 minutes, or miles. And in 6 hours, I go 180 miles. So there's my 4 points. I have graphed them, connect them. And does this meet my 2 points, my 2 things of criteria? 1, does it form a straight line? Straight line?
Yeah.
Yes.
Mm-hmm. Yep. Does it pass through the origin of 0, 0?
Yes.
Therefore, is this direct variation?
Yes.
Yes. Yes, it is. So if we need to graph, that's about how you do it. The other way it'll ask you with some of these tables is same thing, distance and time.
I duplicated my watch.
Distance and time.
It's a bit tight.
Quiet, Daniel, don't care. Distance, 44 miles in 2 hours, 66 miles in 3 hours, 86 miles in 4 hours, and 110 in 5 hours. So this one will make backwards here. We're going to call time X. We'll call distance Y. So I need to figure out my direct variation. So 44, basically it's Y over X. 44 divided by 2 equals 22. Next one, 66 over 3 equals 22. Next one, 86 over 4 equals 21.5. Last one, 110 over 5 equals 22. So now I look at my 4 points, 22, 22, 21.5, and 22. Direct variation. Direct variation, yes or no?
No.
Why not?
Because it's different.
What's different?
That number.
My 3rd point.
It's the imposter.
My 3rd point. My constant. Slope is different than the other 3, isn't it? Therefore, if I plotted this, would not be able to make a straight line.
Almost straight line.
Almost. Close. But I do not have equal. These are not proportionate to each other. Not proportionate. These 3 are proportionate. However, this point right here is not. And by rule, by definition, because the ratios are not equal, that means not direct variation. So you'll deal with that 1 through 4. 5 and 6, you'll test by making a graph. 7 through 18, we've already talked about. And the last thing I need to show you, the word problems. These are definitely going to be the trickiest part of the unit. But you need to set your own proportions now. And you're basically going to be solving to create your own equivalent proportions. Okay. So how is this going to work? So let's do this here. Let's say somebody's pay, we're going to call pay P, right? Pay for P, And we're going to call the number of hours you work H. Okay. So let's say in 12 hours, you make 102 bucks. Now the question is, how much do you make in 37 hours? 37 hours. So there's some different ways to go about approaching this here. And again, I don't want to get this. We can go through and set coordinates and this, that, and the other thing up here. But truthfully, the most efficient way, in my opinion, to solve this is to use equivalent ratios. And that's what you'll need to establish. So whether we set pay to hours or hours to pay doesn't really matter, okay? So whether we have P over H or H over P, not important. You can have it either way. What does matter is whatever one I decide I want to embrace, that when I'm plotting my points, I make sure I keep all my P points either on the top, the bottom, and then the hours different. So what do we want? Pay on top, hours on bottom? Is that good, or you want me to do it the other way?
Other way.
Pay on top, hours on bottom.
So pay on top, hours on bottom. And I'll just do it both ways this one time, just a second. So what is the ratio that I do know? What do I know for sure that I could set as a ratio?
12 over 102.
Yeah, I know. Yep, the other way. I know that in one, I'll make $102 in 12 hours. Right? That's a ratio. I work 12 hours, I'll make 102 bucks. I know that to be true. So if it's equivalent and there's direct variation, what am I solving for? What don't I know?
Pay.
I don't know pay, so I can call that N or just pick a variable. Doesn't matter what I want to use. But I do know it's in 37 hours, right? You agree with all that? So I'll make 102 bucks in 12 hours. So how much will I make in 37 hours? So I can use cross products to solve. You know what cross products are? So I multiply 102 times 37. 102 times 37, that's 3,774 equals 12n. And then solve for n, divide by 12, 3774 divided by 12 equals $314.50. So we'll make $314.50, 37 hours. So just a one-time prove to you, if I went the other way, hours over pay. So 12 hours, 102 bucks equals 37 hours, unknown amount of pay. And I use my cross products once again, 12n equals 3774. And I'll end up at the same spot. So that just proves to you that it doesn't matter which way you set it up. But what does matter is whatever the two things you're comparing, that you keep them on the same line. In this case, I kept pay and pay, hours and hours. Over here, hours and hours, pay and pay. All right? You can't shift that order up at all, because if you do, then you're going to get it wrong. So with these word problems here, they will give you the information you need to set up a ratio. Right? And you can establish it, whatever one of the two values you want on top, such as 19, Wendy's pay in hours. So you can use the exact same thing that I just did here. Okay? No problem at all. Jose, number 20. So on one line, I'll have how much he earns. The other line, how many bucks. And then my equal ratio again, I know how many books, so books will be on the same line, but this time I'll set a variable for how much did he made when he sold 59 books. So I know $601.65 over 63 bucks equals what over 59 bucks? Does it make sense? You guys understand this here?
Yeah.
So it takes a little getting used to, but 19, 20, 21, and 22, you're going to need to establish your own proportions. You're going to be solving for a variable. And that's how you'll want to set it up. You'll want to use the cross products rule to establish your equation, the variable. What are you solving for? And then just solve. It's not difficult to solve, assuming you have a calculator, of course. But not hard with the calculator. You guys know how to solve for a variable at that point. So, and that's it. Questions on the homework?
No. Can we go to bed?
Not yet. No questions on homework? Easy peasy? I think it's